In the next 6 minutes, you are going to make a program that turns on this LED whenever you press on this button using your Arduino's digital inputs. Hi, my name is Jeremy, and welcome to the second tutorial in a series of videos aimed to teach the basics of using an Arduino microcontroller so that you may compete in this semester's Solid State Circuit Society Arduino contest. More information available in the link below. If you have not already, check out our previous videos, as this one will build on their material. Here is a push button. If we remove the cover, we see that this device is made up of 4 connections. The 2 on the left are connected by a wire A, and the 2 on the right are connected by a wire B. Sides A and B are by default not connected to one another. This is known as an open circuit. However, by pressing down on the button, a switch, shown in orange, connects both sides together. This is known as a short circuit. Let us create a circuit that enables the Arduino to detect when the button is pressed. Connect one side of the switch to 5 volts and the other to a resistor leading to ground. The value of this resistor is not critical. Simply try to pick a large value, such as 10 kiloohms. When the button is unpressed, the switch is open and the resistor pulls the output voltage down to ground. However, when the button is pressed, the switch is shorted, pulling the output voltage up to 5 volts. This change in voltage can be read by one of the Arduino's digital inputs. Let us build the circuit. Make sure to unplug your Arduino to avoid shorting any components. Start by reconstructing the circuit from tutorial 1, using an LED, a resistor whose value is around 250 ohms, and 2 wires. However, this time, let's make use of the power rail. Take another wire and split the ground connection in 2. Then, take your push button and place it on the breadboard as shown. Take your 10 kiloohm resistor and connect it to one side of the button. Finally, take 3 wires and finish building the sensing circuit. I have arbitrarily chosen port 5 as my digital input port. However, you may choose any of these ports. Next, let us write the code. Open the Arduino program. We begin where we ended in the previous tutorial video. Before proceeding, let's make this code more readable, so that if we come back in the future, it is easy to understand. We begin by adding comments. A comment is a piece of text that the compiler will not see. You can create a single line comment by adding // at the start of the line. Or you can make a multi-line comment by adding /* at the start and * at the end of a paragraph. Now, say one day we choose to change our digital output from port 13 to, say, port 12. As it stands now, we would need to change the code at every location that refers to this port number, such as here, and even here. This can take time as your code becomes long, and the method is prone to error. Instead, let us modify our code such that we only need to change a single number. We can do so using a variable. Adding a variable is the process of setting a word to be equal to some value. Head to the top of your code. I will arbitrarily call our variable output port, but you may choose any name. Type int output port equals and then your port number, in my case 13. Then, wherever we refer to port 13, we can replace it with output port. As a result, if ever we choose to change this port number, we only need to modify our code in a single location. Now, whereas our old program used an onboard timer to determine when to turn on and off our LED, this new program will control it using our push button. As such, let's add this to our code. Begin by defining the port we will be using as the digital input. I will call this variable input port and will arbitrarily assign it to port 5. Next, initialize this port as a digital input. Within the setup function, type pin mode and then your variable name, in my case input port, and finally input. We will now modify the loop function. Let us start by reading the voltage value. Write bool val equals digital read, and then your variable name, in my case, input port. This is a built-in Arduino function that tells the controller to read the voltage at port input port and set variable val equal to either a 1 or a 0 depending on the input voltage. Next, based on this reading, let us either turn on or off our LED. We can do so by adding an if-else statement. This is a function that allows the code to make a logical decision. Write if val equals 1, bracket bracket, else, bracket bracket. In the first set of brackets, copy over the code that sets the output high. And in the second set of brackets, copy over the code that sets the output low. And you're done. To run the program, plug in your Arduino into your computer and click on the Upload button. This will compile your program and send it to the Arduino. If successful, whenever you press on the button, your LED should light up. If so, congratulations! Feel free to play around with the digital read function. I challenge you to take what we have learned today and try to build a circuit that blinks an LED either slowly or quickly, depending on whether we press or release a button. Join us next video when we will use the serial bus to send the digital reading to our computer.